Okay, here is a video to help you with homework 1 problem 3. Just want to make sure everyone's on the same page and probably try to break habits that maybe you have done in the past. So what we're looking for is the force F here, okay, to keep it at constant speed going up at 0.8 meters per second, okay? Um, You may hear my 3D printer here soon, but it should be, I think you still should be okay. So the first thing you need to do is your sketch, right? So here is the incline. Here is the box. And you have 1, 2, 3, 4 forces. You have the weight. Oh, let's do green. You have the normal force, which is perpendicular to that red surface. You have the friction force, which is down the incline. And then what you have is, let's do it in orange. You have basically this F force. All right. And what you need to do is break this up into components. I would call this F of X. So up the ramp is X, perpendicular to that surface is Y, and then go down. So you have F of Y. So those are your forces. This is actually the same free body diagram for part B as well. All right. For reference right now, for part A, the friction force is mu times N. It's fun. Where B, the friction force is, give me 1 second. I'll show you in my homework help from there, is mu A dV over delta Y. Okay. So it's mu A delta V over delta Y. And really, this is mu A V over H. So delta Y is your thickness, and the change in velocity from the bottom of that surface of the box to the surface is basically V to 0. Okay. So for example, like part B, if I redraw this angle in the box, whoops, what we have is a liquid layer here. That thickness is H, and this box is riding on that now instead of the surface. Okay. And you will get a reduction. It should be about 46%. All right. Now, when I said in the earlier, like break habits, in your solution, write Newton's second law. And this would be for, I would say, A, part A, underline. And this is where you should have the X direction, which is up the ramp. Put a line, Y direction, perpendicular to the ramp, underline. Sum of the forces in the X equals MAX. Sum of the forces in the Y equals MAY. Now, because this is constant up the incline, that AX is 0, and this isn't moving perpendicular, basically like up and down that way, so there's no acceleration in the Y. So what you have is all the forces in the X on the left of the equal sign will equal 0 in the X, and same with the Y. So let's go ahead and write, I'm going to underline these. So we have negative friction plus F of X, and And we need to break W into components. So perpendicular down, WY, and then I'm going to just move this over here. This goes this way. This is WX. Okay, so we have minus WX. Oops. Sure, I can keep it like that. So we have 1, 2, 3, right? In the X equals 0. Now over here in the Y, you have the normal force, positive, minus the weight component, and then minus F of Y equals 0. All right. What I would do next is write this minus, this is part A, this friction force is mu times the normal, plus F of X. All right, so this right here is theta, okay, which is basically, you should be here. Okay, so this is cosine, right? This would be F cosine theta for F of X, right? Which is right here. I'm just going to erase that. Minus, and you'll find that this is also theta because, like, this angle we call alpha, and alpha plus theta is 90, okay? So I will do this as W cosine. No, sorry. W sine theta equals 0, right? Over here, we have the normal, which is normal, and this is just W cosine theta minus F of sine theta equals 0 in the y direction. Let me make sure F of y. Yeah, they did it. They did it slightly different, but that's okay. Sine. Yep. Okay. Now, I believe they gave you W. So what you could do is solve for, in this case, N, which would be W cosine theta plus F sine theta. And then plug that right there. So you'd have minus mu times W cosine theta plus F sine theta, right? Plus F cosine theta minus W sine theta equals 0. And what you can do is you can factor out the F and you can solve for F. Because you have mu, you have W, you have the angle. You can pretty much find now F by using algebra. Okay. This mu is your friction coefficient, not the dynamic viscosity for A. All right. Now for part B, it's like everything is the same except, let me do it green, this friction force right here. Okay. So for part B, write all this down again, but your friction force, what would we have? It would be mu, your dynamic viscosity, times the area times V over H. Okay. And you have all of these. So F actually becomes easier to solve because there's no normal force in there. Right? Because the friction force is this now. There's no normal force reaction. So you can pretty much use the x direction and solve for F. Now, what I'm looking for in this particular problem is how your physics, it's a good review of physics. So set the problem up like I have here, plug some numbers. If you're off by a little bit, that's not the point of this. The point is to make sure you understand free body diagram, sketches, your angles, and the difference between friction force with surface to surface and a friction force with a liquid layer on here. Okay. All right. I hope this helps. And let me know if you have more questions. Thank you.